solve some very simple problems about transpose. So if there are still some confusions about what a transpose is, it should be clarified. But now let's come to inverse, and this is important. This is very important. So what is an inverse? Before we talk about what is an inverse, I'm going to go all the way up, and okay, I've written quite a lot, it turns out. Okay, and remember this system of equation that I had introduced in the first class, and I just introduced this. We solved this system of equations, and that was it. I didn't talk about why. What were we trying to do? So we're going to do that now. We're going to try and establish a connection between system of equations and matrices. So I'm going to write down that system of equations again. So what I had, if I remember, is 2x plus 3y was 8, and I had 7x minus y equals to 5. And as we talked about, this is a 2 by 2 system. A 2 by 2 system. What does that mean? It means we have two equations and we have two variables. Okay. And what we have already talked about is that for a system of equation to be solvable, what we need is that the number of equations to be equal to or greater than the number of variables. Okay. Now, solving a 2 by 2 system of equation is very easy. Solving a 3 by 3 system is also easy. Solving a 4 by 4 system gets a bit more complex, 5 by 4 even more complex. What if you're dealing with a 20 by 20 system of equations? You'll often come across such situations where you have 20 variables with 20 equations. And it's very difficult to solve these problems, this large system of equations, using the methods that we know. The, what do you call them? The simultaneous methods and whatnot. So what we do is we take this system of equation and we convert it into the matrix form. So the matrix form of this system of equation is 2, 3, 7 minus 1 multiplied by x, y, which is equal to 8, 5. What we have done is this is all the coefficients. This right here is all the variables. And this obviously is what we have on the other side, the constants. So we can convert any system of equations into its matrix form. So I'll just write that down as well. So this is a system of equations, and this is the matrix form of the same system of equations. So they're both the same thing. Okay. Okay, so remember what our aim was. Our aim was to find the values of x and y, values of x and y. So what we would do in regular algebra is divide. Okay, let me write this down. We have is, and in regular algebra, what we would do is we would divide both sides by this, which means this and this cancels out, and we are left with just x and y, which is equal to, and here's where we run into problem, because this doesn't make any sense. We have talked about matrix multiplication, fine, but notice we have not talked about matrix division. That is because matrix division is not possible. So we cannot do this. And that is why we need something called the inverse of a matrix. So let's go